Hey guys, so I've been working on this project for a while now, and I'm pretty much almost done with it. I just actually got back from the International Science Fair in Pittsburgh, and I placed second in the world in engineering, and some other things there too. But I'll run down everything and show you how everything works. First of all, we have the stand to hold the robotic arm. I was kind of going for a human-like figure. And my friend and I, we welded it together, and turned out pretty well. Here we have the shoulder. It's pretty much just two giant DC geared motors, and the thing with DC motors is they want to spin as fast as they can for as long as they can, and to get precise movements out of that, it's pretty difficult to. So I had to put two feedback systems on it, which is just a potentiometer. And that pretty much just allows me to know where it's at and to tell it where to go. And combined with all that, I pretty much turned these two DC motors into a giant servo. So I can pretty much tell it to go to 90 degrees. It will go up 90 degrees and it will hold. And I could have done it a different way too, which is just powering the motor in one direction for a certain amount of time until it got to the point I wanted it to stop. But that's not consistent enough, it's not accurate, and with this, this corrects itself, it's reliable, it makes programming easier, and it's just a better system overall. Next we have the bicep. That's pretty much where all the electronics are. You can see my main board is the Arduino Uno. It's pretty packed. I guess it's time to move on to a better board. These two big boards right here, they're from a smart car from China. They're the motor drivers for the two shoulder motors. And then a small one is for the elbow DC motor. To control the arm, I just have push buttons to choose preloaded functions on it right now. I'm still developing a control system for the whole arm. But right now, each button does something different, and then there's one button to confirm the choice. This is the elbow motor. It's a DC motor. It's a 90-degree gearbox, and it was kind of a challenging part to try and mount a potentiometer to a flat piece of metal like that. So I ended up using these plastic pellets that you put in water, and it pretty much just melts them, and then you can form them to whatever shape you want, and then it hardens. And I used that for a good amount of the project, just for supports and to hold everything together. So this is the whole hand. The hand is 3D printed. I designed it in a CAD program. I had it printed out using a Thing-O-Matic, and it turned out pretty well. Each joint has a different screw in it, so you can tension it to control the timing of each joint when it flexes. And then just standard servos to control or to actuate the fingers. And also I have a thumb movement on it. And then back here I have a rotation servo to rotate the whole arm to get it as human-like as possible. For the electronics of the hand, I use an Arduino Uno again, just to control all these servos. I'm controlling 7 servos with them, and it seems to be working okay. I think there's only 6 PWMs on Arduino, but I'm just using another pin and it seems to be working okay. And I'm still kind of playing around to get these two Arduinos to communicate with each other. Say when the robotic arm is shaking your hand, it will tell this Arduino to move the servos to the correct position, so it would kind of talk to each other in sequence. Here is the robotic arm shaking my hand. Here is the robotic arm flexing. I have two main functions for the arm right now, the shake hand function and the flex function, and I'm working on adding more to it just to show the different range of movements on it, just to show what it can do and how it's comparable to a human arm. And if you have any requests of or some ideas of what it could do, please comment below, and I'll try my best to get it going. I've been thinking about having it toss a ball to you, and just to show different kind of cool aspects of what it can do. My main goal for the arm was to make it under $1,000, and I achieved that goal. I'm aiming towards prosthetics now, and that's a huge part is cost for prosthetics. It's a huge industry. More and more people are getting hurt. More and more people are coming back, needing a prosthetic limb. And if I can make a cheap prosthetic arm, that would be huge for the industry.